Our third task is on paper folding. So the thickness in millimeters of a folded sheet of paper after it's folded n times is given by the equation 0.05 times 2 to the n, where n is the number of folds. So what does the number 0.05 represent? So that's the initial thickness. So 0.05, and then it would be millimeters. So now what we need to do is graph this equation. So I'm going to show you how to do that with a graphing calculator. So we just put in y equals, and then we clear this out and put 0.05 times 2, and then to the x power. Then we're just going to graph that. And I'm going to change my window here because the minimum should go from 0. And then we'll say, maybe you could fold the paper in half 10 times. And then the minimum thickness could be 0. And then, we'll say maybe 5. So if we look there, that gave us a much better viewing window. We can see that exponential curve. So how many folds does it take before the sheet is more than 1 millimeter thick? To view that, it's probably easier to look at the table. So if I go back to the table, change my table settings from ask for the independent to auto, go back, and if you look, it's more than 1 after 4 folds. So on the 5th fold, it would be 1 Well, if I look at that, T is the thickness in millimeters. So that would actually be when it is 1 millimeter. But we want before, yep, okay. So 1 millimeter is going to be after 5 folds. It's 1.6 millimeters thick. And then if we look, when it's 10 millimeters, that's 1 centimeter. So the next part asks, when is it 1 centimeter? Well, it's 12.8 millimeters, which is 1.28 centimeters after 8 folds. So now the area of a sheet of paper is 93.5 square inches. Find the remaining visible area of the sheet of paper after it's folded in half, once, twice, and 3 times. So on here, we would say, if I'm writing my equation, my initial value is 93.5. And every time I fold it, that area is going to decrease in half. So here, if I have 0 folds, my area is 93.5. After 1 fold, what I can do is go 93.5 times 0.5 or times half. It's 46.75. Then if I multiply that by 0.5, it's 23.375 after 2. Then I can times that by 3 and get 70.125. So down here, A is 93.5. That's my initial value. And then B, my growth factor is a half. So my exponential equation is y equals 93.5 times 1/2 to the n. So if we graph that now, we can say 93.5 times, in parentheses, 1 divided by 2. I'm going to raise that to the x power, then delete that, close parentheses. Now I'll graph it. Then I got to change my window because remember, we can go from 0 to 10, but my y max, I need to be at like 100. I'm going to count by, say, tens. So you just see here we have exponential decay because we're multiplying by a half. And then my initial value, that's going to be around 93.75. So if I press trace on the function and move over, we can see that the y value is going to start at about 93.5, or at exactly 93.5. So in this context, can n ever take on negative values? So can n be negative? So n is the number of times it can be folded. So n cannot be negative. Because you can't have a negative number of folds. You have to have 0, 1, 2. So what we can say is because the number of folds has to be a whole number. So then can A take on negative values? So if I'm looking on that, the area can't be negative. Area has to be greater than 0. So A, the area, has to be greater than 0.